Hey guys, I hope you all are doing good. In this lecture, we will try to understand what are maximal and minimal elements and also understand what are greatest and least elements, right? I've separated both of these concepts on the board because usually students face a confusion in understanding the difference between these two concepts, right? So I'll try to explain maximal and minimal elements first, followed by greatest and least elements. And then I'll try to explain what is the difference between both of them, right? That is very important to understand. So before we start this video, just a prerequisites for this video is that you understand what are partial order relations, right? Which basically means relations which are reflexive, anti-symmetric, and transitive, right? So that's the first requisite that you should understand in order to understand this lecture. And second thing is you should understand what are Hasse diagrams, right? So if you understand what is diagram representation, converting it into a Hasse diagram, and then I think you would be able to understand this lecture in this case. But if you haven't covered these concepts before, then I would highly suggest that you do so because you would not be able to understand what these concepts basically mean, right? So let's start with understanding what are maximal and minimal elements, right? An element M is minimal if there is no element uh, x which is not equal to m such that x is less than m, right? What we are trying to say is there is no such element, right, in this relation such that this value is less than it. Now, before we try to understand what are minimal and maximal elements, right? Um, in this definition, we see this less than sign, right? What does it mean really? Right? This is not generally that we're talking about numbers in this case, right? It's not generally like 2, 3, 4 natural numbers, real numbers, etc. So in this case, in terms of relations, this less than to sign, right? So when I say x is less than some value y, in terms of relations, this means x is related to y, right? That is what this means. So I hope you're able to understand it. Also, this also means that x is not equal to y. That is, they are both distinct values and x is related to y, not y related to x, right? Not the other way around. So I hope you're able to understand what does the less than sign means. Now let's try to understand what is the minimal element once again. An element M is the minimal if there is no element x which is not equal to it such that x is less than m. Let's try to understand what this means with the Hasse diagram, right? Let's say I have this diagram A, B, C, D, right? What we're trying to say is there is no element such that x is less than m, such that this value, there is no such value which is less than this value, right? So the basic point is, if you look at this diagram in this case, I see A is less than B, right? Which is A is related to B. B is related to C, right? I'm not using the R sign, I'm using the less than sign instead in this case, right? B is less than D, but remember, C is not less than D or D is not less than C. That's not something that we have been given. So that's not something we have to worry about, right? So A is less than B, B is less than C, B is less than D as well. We don't know about C or D in this case, right? But one thing is for sure, also, we also have A is less than C and A is less than D as well, right? So what is the minimal element in this case? If you look at it, A over here is going to be the minimal element. Why? Because I don't see any value which is lower than A in this case. So in very simple words, right, if you see a Hasse diagram, whatever is the lowest value, right, which whatever is on the lowest level is going to be the least element. Or sorry, I should say is going to be the minimal element in this case, right? So let's say I had this other diagram. Let's say I had A, B, C, D. If I ask you the question, what is the minimal element in this case? It is going to be both A and B, right? So once again, just a quick definition. Um, a value is a minimal element in a relation if there is no such value x which is less than it, right? So if there is a value x less than it, then we can say it is not minimal. D has a value less than it, or I can say A is related to D, right? That's why D is not minimal, C is not minimal, A and B are. But if you don't understand this definition, just keep a very simple term in mind. Whenever you say Hasse diagram on board, the least value or the lowest level, right? Lowest level plus all the values which don't have any value less than it, right, are going to be the minimal elements, right? Now let's try to understand what is the maximal element. An element m is the maximal if there is no value x such that m is less than it. So in this case, when in terms of Hasse diagram, what we are talking about is on the diagram, all the values which lie on the topmost level are going to be the maximal elements, right? So in this diagram, C and D are going to be the maximal elements. And in this case as well, C and D are going to be maximal elements. Now, if I give you another example, right? Let's say I give you this case. Let's say I have this B, C, D, and A. Now, if I have to figure out, or if I ask you this question, what is the maximal element and what are the minimal elements? You can pause this video and try to figure out, right? So the answer is very simple. Minimal element is one that lies on the very bottom level. So it's going to be A in this case. Maximal element are going to be the one that lie on the topmost level, or in general, in actual definition, there is no value that is actually less than it, or I should say, no value that is actually greater than it, right? So in this case, B, C, D are those values, right? Another way to explain maximal and minimal elements is we're talking about relations, right? So I can say when I say C and D are maximal elements, I'm saying that C and D are not related to any other elements, right? So once again, maximal elements means C and D are not related to any other elements. When I talk about when I talk about the minimal elements, I mean no element other than A is related to itself, right? Kind of a tricky definition to understand, but I hope you understand the general concept behind it. So now let's try to understand what are the greatest and least elements. One more thing to note over here is there can be multiple maximal and minimal elements, right? So for example, in this case, I have two minimal elements. In this case, I have two maximal elements, right? In this case, I have three maximal elements, right? Okay. So now let's try to understand what are the greatest and the least elements. And I think from the definition, you might be able to understand a bit of the difference, but I'll still explain what it means, right? Okay, an element G is the greatest element if G is greater than equal to X for all the values of X in the set A, right? And least element, an element L, is the least element if L is less than equal to X for all the values of X in the set A. Look, the point is that the difference between both the maximal minimal elements and the greatest and least elements is that greatest and least elements are always unique, right? There's only one greatest and one least elements, not both, right? In maximal and minimal elements, you can have multiple ones, right? But in greatest and least, there can only be one. And the reason is the way of comparison is different, right? In this case, in terms of maximal and minimal elements, I try to check if there's any value which is less than that on my diagram, right? For example, is there any value lower than A? No, right? So I can say A is the minimal element. There's no value lower than B, I can say it's the minimal element. But in this case, I'm saying element G is greatest if G is greater than equal to X for all the values, right? It has to be compared to all the values I have in my diagram. So let's try to solve this with an example. Again, I'm going to take the same example once again, A, B, C, D. Now, if I ask you the question, is A the, or I should say, do you think is D the greatest element in this case? Let's try to understand this, right? Now, according to the definition, is greatest if G is greater than equal to X for all the values. But the answer in this case is going to be D is not the greatest element and C is also not the greatest element. And the answer is that there is actually no greatest element in this case, right? But if I had made one change, right? Let's say I didn't have this C instead. In this case, I can say that D is the greatest element. Why? Because D is greater than B and D is also greater than A in this case, right? Once again, if you remember correctly, in a Hasse diagram, we are going in the upwards direction, right? And that is why D is going to be the greatest element. But when I have C, right? In this case, I don't know if D is greater than C or I don't know if C is greater than D in this case, right? Because there is actually no arrow going from one to the other. And that is why I cannot say what is the greatest element in this case. But do you think I can figure out what is the least element? And the answer is yes, right? And what is the definition? Let's just try to understand the definition in this case. An element L is the least element if L is less than equal to x for all the values x which are elements of A. So once again, in the least element, I'm supposed to compare the least value with all the values, right? If I cannot compare it to all the values, then there is no least element. In this case, I see A is less than B, A is less than D, A is also less than C, right? So I can say A is least element. But do you think there is any greatest element? The answer is no. Let's take a look at another example, right? Let's say I have this A, B, C, and D. Do you think there is any greatest element? The answer is no. Why? Because I don't know if C, I cannot compare this C to this D. I cannot compare this D to this C. Similarly, when I take a look at the lowest level, I cannot compare this A to B, I cannot compare this B to A. According to the definitions, I should be able to compare all the elements to all the other elements, right? I should be able to compare this A to C, D, B, and this D to A, B, C in order for it to be the least or the greatest element. So, quick summary once again, an element G is greatest if G is greater than equal to X. So it always has to be that there is a unique element at the bottom or a unique element at the top, right? In very simple words, if you're not able to understand what I've just explained, in the very simple words, right, at the very simple level, when you see the diagram, when you see the Hasse diagram, and you see that there's only one unique element at the very top, then that means that's the greatest element as well as the maximal element. If you see a unique element at the very bottom and it's connected to all the other nodes, right, then you can say that it is the least element. But if you see multiple values at the bottom or multiple values at the top, then you can say that there is no greatest or no least element, depending on if you have multiple elements, right? Similarly, in the case of maximal and minimal elements, there can be multiple values. The way of comparison in both of them is different, right? So it is very important to remember what is the definition difference in both of them, right? So I think this was a lot of explanation in this lecture. I hope you were able to understand it. Now I'll be giving a bunch of questions for you guys to solve, but I don't think you would be given like just a general relation to solve. Generally, you would be given Hasse diagrams and you would be asked to figure out what is the maximal or what are the minimal elements or what are the greatest and the least elements, right? And I think you have already figured out how we can do it. So now I'll be giving a bunch of questions for you guys to solve, and then we will move on to the next lecture. Okay, one more thing before I move on, let me just formalize the comparison between maximal and minimal elements and greatest and least elements. So if I have max min on one side, right, and so I'm just going to draw this table, right? Let's say I have comparable and unique. So in case of max dash min, uh, we don't necessarily have to compare them. So I can say no. In case of great slash least, we have to compare them and we have to compare all of them, right? Are they unique, maximal and minimal? That is going to be no. Greatest and least, they have to be unique. So that is going to be yes, right? So just a very small table. Comparable basically means that you have to compare all of them. In maximal and minimal, you don't, but in greatest and least, you have to compare, right? In case of unique, maximal and minimal elements don't have to be unique, they can be multiple. But in the case of greatest and least, there has to be a unique great or a least element, right? So now let's move on to the questions. Okay, so I've given two questions on the board, should be pretty easy to solve, right? But they would give you a clear idea about what is the meaning of maximal minimal elements slash greatest or least element, right? So the first thing is let A be the set. This is basically the power set, you can say, and you need to figure out the relation is the subset, right? So if something is the subset of the other, then you can say they are related to each other. Otherwise, they're not, right? So For this question, you should have a good understanding about sets as well, right? So I hope you will be able to solve it. If not, then you can just always revise sets again and then try to solve this question, right? Now, you're supposed to find the maximal and minimal elements and the greatest and the least element, right? My quick approach or idea that I would like to give you guys is maybe you can draw the Hasse diagram for it, right? And then from the Hasse diagram, it should be pretty simple to figure out what is the greatest slash least element and what are the maximal slash minimal elements, right? Second question is also pretty easy to solve. Determine whether the posets have greatest or least element, and I think you would be able to figure that out, right? So that was it for this lecture. In the next lecture, again, we will be covering a bit of definitions, right? So I'll see you guys in the next video.